Hello, my name is Torron Willis, and today I will be doing a presentation over Escherichia coli, also known as E. coli. Thank you, and please enjoy. E. coli is a gram-negative, facilitated anaerobia, and many strains are motile in lactose fermenters on selected media, which makes them straightforward to identify in the lab. Remember that pathogenic behaviors is not inherent to every E. coli disease, comes from a few added genes carried on mobile elements that change how certain strains interact with their host. Different pathotypes of E. coli cause very different clinical pictures. Some attack the gut and cause diarrheal disease. Others invade outside the intestine to cause UTIs, sepsis, and neonatal meningitis. When clinicals say E. coli, they mean the spectrum of organisms, so it's critical to link specific pathotypes to their typical diseases for diagnosis and management. The damage caused by pathogenic E. coli is driven by a handful of powerful factors. Shiga toxins halt protein synthesis and can trigger HUS. Exterotoxins drive secretory diarrhea, and adhesins dictate whether bacteria stick and establish infection. These virulence tools explain both the clinical severity and why some strains spread so fast and effectively in foodborne outbreaks. Transmission is primarily fecal, oral, or contaminated food, water, or hands are the usual culprits. The common outbreak vehicles include undercooked ground beef, raw dairy, and contaminated produce, or recreational water. Breaking the transmission chain is simple in principle: cook, clean, and protect water supplies, but requires consistent practice in public health systems that detect contamination quickly to stop any outbreak or any case of this getting out. Laboratory diagnosis ranges from routine stool and urine cultures to rapid toxin assays in PCR for STEC, and modern outbreak workups rely on whole genome sequencing to link cases. Rapid and accurate identification not only guides clinical care, such as avoiding antibiotics in some STEC cases, but also enables effective public health responses to stop further spread. E. coli is a leading carrier of clinically important resistance mechanism. ESBLS, AMPC, and carpinemasis spread on plasmids and make common infections harder to treat. This trend forces reliance on susceptibility testing, careful antibiotic selection, and rigorous stewardship to preserve treatment options for UTIs and invasive infections. You can find E. coli everywhere in life and waste. Intersects with human and animal intestines, water waste, food, environments, and surface water. So surveillance at these points gives early warning of contamination. It's worth emphasizing that the same species that causes several diseases also underpins molecular biology and biotech, illustrating how context and specific genetic makeup determine risk for catching this disease. Prevention is straightforward and evidence based. Cook meat to safe temperatures to make sure all bacteria are dead. Avoid unpasteurized products and eat more pasteurized or use pasteurized products. Practice rigorous hand hygiene, making sure that your surface and everywhere that you're cleaning is always sanitary, and ensure water is treated and sanitary, and that your water systems are also treated and maintained. On the public health side, rapid detection, tracebacks, and transparent communication are what turn isolated cases into contaminated incidents instead of large outbreaks. Thank you, and I hope you enjoyed this presentation.